Greetings, and welcome to part 1 of the MetLogix M3 version 3 tutorial series. In part 1, we will be discussing the Advanced Edge Teach tool. The new Advanced Edge Teach tool is designed to assist in the fine-tune adjustment of edge detection parameters for difficult-to-image edges. Low contrast, narrow, and noisy edges can be honed in on by adjusting of the threshold bar in the new Advanced Edge Teach graph. This new Advanced Edge Teach feature is available for use with any of the currently supported M3 VED probes. By default, the new Advanced Edge Teach capability is disabled. To enable the new Advanced Edge Teach, navigate to the M3 Menus page, the Video Setup screen, and set the flag Use Advanced Teach to Yes. The new Advanced Edge Teach feature is invoked in the same method that the Automatic Edge Teach that is currently supported in the M3 is called. Long press on the edge that you would like to teach on. The magnification window appears and provides you feedback as to the detected edge contrast that will be taught on. Release the left mouse button and the Advanced Edge Teach stitch is drawn in the video window, and the new Advanced Edge Teach dialog is called in the left viewport. When setting a new Advanced Edge Teach, the system will automatically calculate the parameters that it determines to be correct for the edge transition detected. It is these parameters that can now be adjusted by interacting with the new Advanced Edge Teach dialog. Press Done to store the settings of the teach setup to the current video probe. You will see that the video probe displayed in the toolbar is highlighted in an orange color to indicate that a teach is in place. To remove a set teach, use the Unteach button in the bottom of the toolbar that will be displayed when any teach is in place. You will see that after pressing the Unteach button, the tools are displayed back in their standard monochrome fashion. The Advanced Edge Teach dialog can be called from either the Measure Logic probe, the iMeasure probe, or the new Simple Active Crosshair probe. I will stop to make a point about this new Simple Active Crosshair probe. In the M3 V3 software, we have made a change to the behavior of the Simple Active Crosshair. As you will see, the new Simple Active Crosshair can be sized, and its edge detection sense can be set using the sizing and edge scan handles as seen here. The scan direction and color sense control is the same that's available in the current release of the software with the iMeasure probe. One of the other changes you'll notice is that I can freely translate this new Simple Active Crosshair in my field of view. Unlike the current M3 software, the probe will not automatically recenter to the middle of the field of view. If you'd like to do so, simply long press the Translate Rotate to recenter the probe. One of the other differences you'll note about the Simple Active Crosshair in this mode is that the scan across the edge transition occurs directly along the line of the crosshair probe itself. You can note this by putting the probe into rotate mode and see the edge candidate position move along the edge directly along the horizontal scan line in this case. This should provide the user the ability to identify edges in a much more straightforward fashion without relying on the automatic edge detection capability supported in the Active Crosshair in the current M3 release. Users who are accustomed to using the simple active crosshair in the traditional fashion can still do so by using the click to measure feature. Press measure line, interact with the video window to probe your line feature. Now let's take a closer look at the new Advanced Edge Teach dialog window. For this example, I'm going to draw an iMeasure probe across this edge transition. Long press inside the iMeasure to call the Advanced Edge Teach dialog. You will notice in the new Advanced Edge Teach dialog, we have a small magnification window giving the operator a display of the edge that he has centered on. Below that is the edge contrast data graph. The edge contrast data graph can be adjusted to set the threshold for edge detection in a way whereby the candidate measurement is aligned with the edge transition the operator is attempting to collect. You can see in this example, as I drag the edge contrast threshold bar up and down, the state of the active collected data is adjusted real-time in the live video window. One thing to note is that the edge contrast data graph is always displayed with a scan direction from left to right in the graph. What this means is that when a scan direction and color sense is set directly in the video probe in the live video window, it corresponds to a left and right direction in the graph. Below the edge contrast data graph is the edge thickness filter. The edge thickness filter is in the unit of pixels. This filter detects the minimum edge thickness that will be detected by the current probe. The following shows a good example of this edge thickness contrast being applied to the current live video probe. As was the case with the current Advanced Edge Teach, when a part program is generated containing taught data, the edge detection data is stored inside the feature measurement itself for use in program playback. Thank you.